In this video, we'll be talking about acids and bases in chemistry, providing some visual representations to allow you to understand how these different acids and bases interact with each other and transform back and forth into various stages. Okay, so let's start off with the basic concept of what an acid is and what a base is. So an acid is, usually you can think about it on the pH scale as being in the lower end of the scale from usually 0 to 4. And these acids are acidic because they typically have the hydronium ion. They have an additional ion that allows them to be acidic. They can then donate during reactions like the ones depicted here. Base, on the other hand, they are typically a part of alkaline solutions, and you probably have heard the word alkaline before because that means a solution is higher up on the pH scale. It's usually from 8 to 12. Some examples of an alkaline solutions are drain cleaners, which are usually containing high base content, and acids, on the other hand, like citric acid, for example. The found in citrus is a common component there. Okay, so we have here a few visual representations of interactions and reactions between acids and bases and what's going on here. Okay, let's start off with this first one up here. So what are we looking at? We have our typical water, H2O, and we have our NH3 over here, nitrogen and hydrogen. Then we have a product. These are the products. The right side of the arrow here is always the product of the reaction. We have OH minus, so you can see we start off with H2O. Whoops, what's going on? We have H2O in the beginning, and by the end of it, we have OH minus. We have one less hydrogen. We only have one hydrogen now. Before we had two. The hydrogen's the white here, the white blobs, the Mickey Mouse ears, if you will. But now here we only have one on top, and whenever you lose a component there, you're taking it away, you're going to give the entire ion a negative charge. So this is a negative charged ion now. Now we have the NH3 situation. We start off with 3 hydrogens surrounding the central nitrogen. But at the end of it, we end up with 4 hydrogens. We have one more hydrogen here. And if we add something, it's going to be the reverse of what we had before. It's going to become positive now. So we went from NH3, only 3 hydrogens, to NH4. How did we do that? Okay, and how we do it for the hydrogen as well. Okay, so here's what's going on. We have interactions between the acid and the base. Now, there's a very important and very fundamental principle that governs why these sorts of reactions can happen. And it's all part of a principle that says all acids, bases accept and acids donate. That's the acronym there. So bases accept your additional hydrogens in this case because you've got the base, NH3, going to NH4. The NH3 is accepting an additional hydrogen. It's going up to H4. Now, where is it accepting it from? That's where the H2O comes in. Now, you notice H2O is losing a hydrogen. It's going down to only 1. And where does that hydrogen go? It goes onto the NH form to make it go up from NH3 to NH4. So as you can see, the H plus acceptor here, the base, has accepted the hydrogen from the donor acid. So we have here water. The H plus donor is the acid because it donates that one hydrogen to the NH3. It's basically like, okay, let's go ahead and exchange here. They're exchanging the hydrogens, and that's essentially what's happening in this reaction. Okay, now we have actually the reverse. It's the same exact thing but going in the opposite order. And in fact, you can view any chemical reaction involving acids and bases 2 ways. You can read from left to right like we have up here, or you could read from right to left like down here. So it's the reverse. We have the NH4 is now the donor acid. So it's donating the hydrogen to the H2O, so it becomes water. See, now it's only 3, start off as 4. But up here, it was the acceptor base. So they switched roles, basically. Now we begin with, now we have the water is the acceptor base. So it starts off with OH minus and it becomes H2O because it gets an additional hydrogen. Okay, now let's look at another variation of this. This is basically just an expanded or simplified version of these two pictures or these depictions up here because we're essentially combining them into one visualization because we have the arrow here is going and it's pointing in both directions. It's pointing to the right, pointing to the left. It's saying, okay, we're having these two reactions happening simultaneously. It could go either way. We have the acid and the base. We have the base and the acid. They flip roles. Okay. Now, let's look at one more unrelated example here containing a little bit of different elements and different atoms. So we have HCl. The green part is the chlorine. Just so you know, the green usually symbolizes chlorine. Okay, and in this case, the HCl is the donor acid because it's donating that one white hydrogen there, as you can see, to the H2O. It's just chlorine minus here. There's no hydrogen anymore. And that hydrogen goes over here onto the H2O to make it H3O positive. And this H3O positive right here is also known as a hydronium ion. Hydronium ion. Okay. And that is formed during this reaction because of the interaction between the acid and the base, the H plus donor and the H plus acceptor. Okay, well, that's pretty much it for acid and bases chemistry and how these atoms interact with each other to create new products involving the specific properties of donor acids and acceptor bases, or in some cases, acceptor bases and donor acids. The role is reversed based on which direction you're reading the reaction from. Okay, and that was an overview of acids and bases in chemistry and some visual representations.